Welcome to First and Future Live. This is the bi-weekly program of the Institute for Emerging Issues at NC State University. Each week, each show, which we do every other week, we focus on a different big issue facing the state of North Carolina and talk with some of the people who have ideas about how to make progress on it. My name's Leslie Boney, and I'm the director of the Institute for Emerging Issues, and we're really glad that you joined us, whether you're joining by Facebook Live or by LinkedIn Live or over YouTube. Some of you are watching a recording of this on our YouTube channel. Others are watching the show off of our website, emergingissues.org, or via a podcast feed. Regardless of how you got here or when you're listening, we thank you for being with us. We ask that you submit your questions about an important topic that we're taking on today, and that is what happens to people between the time that they enter college as a freshman up till the time that they go to work when it comes to science, technology, engineering, and math, the STEM disciplines. We're doing the show today, July 20th, because this is a huge day for people like me who are of a certain age. And if you are of a certain age, you remember exactly where you were on July 20th, 1969. That is the year that my family and I were hunkered down around a 13-inch black and white TV set. My father was holding the antenna to make sure we could actually get the reception. And it had already been a big week. On July 16th of that week, 3 guys had loaded onto the top of an exploding rocket. They had then traveled for 6 hours, 35 minutes, 4 days, 6 hours and 35 minutes. And then 2 of them had set down on a giant pile of rock 238,855 miles away. A little bit later, Neil Armstrong got out, climbed down a ladder, and set foot on.
It's one small step for man, one giant leap for mankind.
A lot of you have heard the controversy over what Neil Armstrong thinks he said versus what other people think he said. He thinks he said that's one small step for a man, one giant leap for mankind. There's been controversy about that ever since. But what there hasn't been controversy about is that the result of that whole space race was an explosion in the percentage of people who were coming out of college with STEM majors. The following year, 1970, represented the high water mark for people graduating with degrees in the STEM disciplines. Science was cool. Studying was cool. Being smart was cool. And that was the year that we have not reached since, the percentage of people getting STEM undergraduate and graduate degrees. The question is, why does it matter, and what can we do about it? Will the amazing feats of the coronavirus vaccine producers over the past year, or the heroic work of healthcare workers, will that make any kind of difference? Will Jeff Bezos, who right now is getting ready to explode into space, will he attract some attention and get some more people to go into the STEM disciplines? Today, on the 52nd anniversary of one of the STEMmiest success stories in human history, we take a look at that question. And more particularly, we're going to look at what we can do to increase the percentage of women and people from underrepresented groups going to work in STEM. Let me just start with a little bit of scene setting. Why should we care about STEM? Part of the answer is that STEM is where the jobs are, especially in North Carolina of late. This is a chart put together by Tom White, North Carolina State's economic developer, where he looked at the number of announcements just in the field of life sciences over the past year. You'll see 725 new jobs announced in Holly Springs in March of 2021. And the list goes on beyond that. You'll see some jobs announced in Greenville in December by Thermo Fisher Scientific, in Clayton by Grifols. And you add those up. Those are just the STEM jobs announced in big plant expansions over the past year. There are many more than that if you broaden out beyond there. So that's one reason. That's where the jobs are. The second reason, I think, is that that's where a lot of the good jobs are. So those who are working in the STEM professions make, the median worker makes 65% more than those in other jobs. According to Pew, The median wage for someone in a STEM job is $77,400 compared to $46,900 for those in non-STEM jobs. So we know that STEM jobs pay more. But a lot can happen on the way to work in a STEM job. So today, on the anniversary of the lunar landing that launched 10,000 scientists, we take a look at a key time in the life of potential STEMsters, that period while they're studying in college and until they connect to the workplace. Joining us are three guests: Dr. Jamila Simpson, Assistant Dean in the College of Sciences at NC State; Dr. Peter Harries, the Dean of the Graduate School at NC State; and Dr. Thomas Redd, an Assistant Professor of Mathematics at NC A&T State University. Thank you all for joining us.
Thanks for having us, Leslie.
Yeah.
Let me start with a question for all of you. A lot of people change majors, and a lot of people decide not to go to work in the fields that they majored in. Why does it make particular sense to put a real focus on STEM majors and holding on to them and trying to get them to go to work in the fields that they've studied in? I'm not going to call you out. Peter, why don't you start? You've spent a lot of time thinking about that connection thing. And
No, and I think, yeah, thanks, Leslie. And I just, you looked at the biological sciences. I just quickly want to go back to the data. But obviously, with people like Google and Apple move in here, I mean, there's a very broad ecospace in which STEM majors are relevant. And I think, the importance of keeping people in those disciplines ultimately relates to, from a state perspective, the economic success of the region, right? I mean, we're very fortunate to be in this triangle area with any number of schools, and certainly going up to the triad as well. I mean, we have an amazing capacity to produce STEM graduates, and that's what's bringing people to the state, is that intellectual power that exists. So focusing on STEM and keeping to develop that STEM pipeline is critical, not only for the state, but more broadly to the advances that we can make as a society and globally. I mean, there's so many grand challenges around that require, certainly beyond STEM, you need a variety of people to address those, but that STEM core is really central to just our being as a people.
Jamila, you've decided to spend at least part of your career focused on the STEM disciplines and helping people to stay in those disciplines. Why is that so important to you?
So when I was a kid, I wanted to chase tornadoes. And there were times where I wanted to talk about that in school, and there just was not the opportunity. And so in my K-12 experience, I realized that there are a lot of people, including educators, that aren't comfortable with STEM. And I saw that as being a huge issue, because I think there are a lot of people out there of all backgrounds that really are passionate about STEM. And the reason they don't pursue it further is it ends up becoming like a childhood dream, where I loved dinosaurs when I was a child. And then I grew up and then I got like a real job. And so I love tornadoes. And
hey, Jamila, I'm a paleontologist. Sorry, just to jump in for a second.
Yeah, right. And my son loves dinosaurs. Because I work at NC State and I have colleagues who are paleontologists like you, Peter. I know that's not a pipe dream. It can be a reality, but I think in our society, for people who tend to love STEM, it ends up being, well, that was a role in a movie, but that's not a real job. And these are real opportunities. For myself, I ended up coming to NC State and I have an undergraduate degree in meteorology. And when I graduated, I found I was the first African-American woman to earn that degree from NC State. And that was a shocker. And so I thought, I'm not the first one to fall in love with the weather, but for some reason there were roadblocks, obstacles, things like that got in the way of other people attaining those degrees. And so that made me want to really pursue, well, what is happening K through all the way through PhD to lose people to STEM, away from STEM. And so my master's and PhD are in science education, specifically looking at the culture of STEM and that being some of the reasons why we're losing students in those disciplines. So it's for me, I tell students I don't mind losing them to their passion in any area, but what I don't want to lose them to is a stereotype of what a scientist or engineer or mathematician looks like. That's what I don't want to lose them to.
Thomas, you're at North Carolina A&T State University. You're an assistant professor of mathematics there, and you've seen the numbers about what happens to math majors in particular. Count me among them. I came in and was determined to be a math major until I collided with intermediate calculus, at which point my brain exploded and I left and didn't look back. But a lot of math majors move away, and a lot of other people run into math on their way to a STEM degree, and they get discouraged. What are you learning about what it takes to get someone through a really tough math course and keep them in when they might be tempted to bail?
So first, Leslie, just in the context of making sure that representation is out, I am an associate professor, just to clarify for someone out there who may be wondering if they can do it.
Apologies.
So math is, when you're talking about math majors, I know sometimes you will have situations where students arrive at college, and they're trying to figure out what they're going to do. And the first thing that goes through their mind is, based on their exposure from high school, hey, I was always good in math in high school, so let me declare this as my major. And they're choosing something that they're familiar with, but maybe that they don't have a passion for, or maybe that they don't fully understand what's involved. Because for math is somewhat unique in that it's so sequential. It's often so sequential, and each course builds on the last course. So if you have a student who just finished high school and the highest math they completed was pre-calculus or calculus, they worked their way up to this terminal class for that level. And then and it may be taught as a terminal class is. And for people who are instructors, I guess you can read between the lines on that portion, but it's taught as a terminal class might be, that's optional for a lot of those students, versus being the first course that the rest of their college career is going to be based on. And so when they get to college, they start out and they take calculus again, or they may take Cal 2 if they did particularly well in that high school calculus course. And the depth and rigor that might be expected at that level, it may not jive with the high school level. So it makes someone start to question whether or not they should continue on this path, whether it's the path that's correct for them. For some cultures and some groups, it may invoke the imposter syndrome, this question of whether or not I should be here and whether or not I can play on this field. So I think all of those things play a role in whether or not we can retain students beyond just the way we're instructing them, but what's that intrinsic motivation, what's their expectation, and then how are we supporting them once they're on campus.
Jamila, you pay particular attention to student success in the North Carolina State College of Sciences, but particularly the success of students of color. And I wanted to show a national statistic that maybe gives a little bit of a context to part of the challenge that we face. It is a slide that shows the percentage of people from different groups, African Americans and Latinx and whites, who switch majors out of STEM by race and ethnicity, and then those that end up dropping out that start off as STEM majors. And the numbers are higher for those underrepresented groups. And something Thomas just mentioned, I think, resonated with me, and that is maybe, and you mentioned earlier that maybe you don't see others who look like you in those fields, or there are particular challenges, or you have imposter syndrome. You've been doing a lot of work on a lot of different programs. Can you talk about what NC State is trying to do to help those from underrepresented groups persist in the STEM disciplines?
Absolutely. So I do diversity in the College of Sciences. I work very closely with my colleague in the Colleges of Engineering, Ag and Life Sciences, so other STEM colleges at NC State, because we do know that for particular groups, actually for all of Americans, there's a stereotype of what does a scientist look like. And there is an actual test called a Draw a Scientist test. They've done it with children and educators. And if you ask someone to draw a scientist, they usually draw a stereotypical, you know, Doc from or Einstein type of caricature. And so I do this with my freshmen of color who are in a class with me. I just tell them to draw a scientist. Imagine a real scientist working on science. I don't tell them where, I don't tell them a lab, just say working on science. And they often, these are all students of color majoring in the sciences, and they often draw the stereotype of an older white man, crazy hair, there's a lab explosion, you know, something to that effect, that they've gotten from media, cartoons, television, movies. And what I find is this idea of the stereotype of a scientist, as Thomas was saying, when you hit those bumps in those classes, and all of us do. I mean, this is a tough curricula. When you hit those bumps, then you begin to say, "Am I cut out for this?" Instead of understanding this is tough, and it was tough for that professor who's teaching it, and others that came before them. And so a lot of the work and programs that myself and colleagues do is saying, you are a scientist, you can do it. Know that these bumps are going to come. Here are alumni who have been successful. So working on the idea of they are STEMist right now, and that this is progress, and it's progress for all of us that study STEM, and that there are others who've come before them. And here is the culture of STEM. So be very clear about what that is, because what they see is others become successful, and they think that it was just inherently they were successful instead of someone explained the culture of STEM to them.
Yeah, can I just jump in for a second too, just to build on that a little bit? Because Jamil and other colleagues are also working with us in the grad school to help build pipelines from the undergrad realm to the graduate school. And we're, until about 2 years ago, we were kind of working in disparate ways. And I think we finally created an ecosystem that works between undergrad and grad. And I think, that's going to bear significant fruit as we move forward, because we certainly want these people to go on and get graduate degrees, whether it's at NC State or somewhere else, but also to give them the tools to sort of demystify grad education, especially for people who are first time in college. Undergraduate is mysterious enough. Grad school is something completely different. So how do we help build that sort of capacity to increase the diversity of our graduate degrees too? Because I think, once again, that's critical to any sort of problem solving we're going to do, is having all of those different perspectives being brought to bear. So I think we're beginning to create some really significant synergies that hopefully will result in, significant changes in a variety of ways.
Thomas, NCA&T regularly each year graduates more African American engineers than any other university in the country. And you and your colleagues have been doing a lot of work on other folks in the sciences, technology, engineering, and math there. What are some of the strategies that you use to help retain undergraduate STEM majors, but also to encourage some of them to go on to graduate studies, as Peter was talking about?
So there's a lot of interventions that are used for, I guess, for retention. We've tried some different interventions at the earlier levels of their academic careers. I think a lot of times there's this idea that works out pretty well in practice, but once the student gets to their upper level classes, we can usually get them the rest of the way out. It's trying to retain them in the earlier phases. And so we've had a lot of interventions, especially in the math department, to try and address that. And that's involved some different pedagogical avenues. So we've used Emporium models for some of our courses, and we've used the scale-up model that I'm sure you guys are really familiar with over at NC State, to try and flip our classrooms and make it more, the first two letters of scale-up are student-centered. So we try and make it a much more student-centered approach. We've had interventions with extra time for the students and extra interactions with the students outside of class. So all of those things have worked to help stabilize our numbers at this point. And once they've been stabilized, we're actually starting to improve the numbers in terms of our retention rates. So we've had the Emporium model implemented, we've had Scale Up implemented, and as of last year, we went through our SACS-free accreditation process. And our QEP was focused on math and communication, so our quality enhancement plan. And I don't know whether I should go very far into SACS and what all of that means, but basically it's where we had to take an internal look at our campus and identify where we wanted to make some improvements, some areas where we could improve, and as a community come together and say, yes, this is what we're going to work on for the next 5 years. So math was one of those areas to help make sure that students would be able to, students who wanted to pursue a discipline didn't view math or run into math as the ultimate decision maker as to whether or not they continued on that track.
Yeah, so this is not just students who are math majors, but it's students for whom getting through another major have to take certain math courses, and that may be the one that discourages them. So any strategies that you found for non-math majors to help them through that math course and increase their probability of persisting?
So one of the biggest strategies is content relevance, trying to help those students understand that math isn't a necessary evil. It's their major is asking them to take a particular class for a reason. There is something that they want to get out of it. In a perfect world, we'd be able to take each individual student and say, okay, here's the general problem, and this is how it applies directly to you. But there's only one math instructor and a number of students in the class, so that can be difficult. So one of the big strategies is engaging the rest of the campus and helping to bring forward that content relevance for all of the students on campus. And by helping them to see how it directly impacts their success in their chosen major, their future earning potential, then we're hoping, because this is a study, this is an intervention we're hoping that it's going to help to improve retention for the campus as a whole, but also retention within each major. It's not a problem if a student leaves a major for a different major that they feel is more in line with their interests. But if they wanted a particular major and can't complete that particular major due to math or due to lack of support, then we have a problem.
Jamila, you've developed a number of programs designed to help people face down the particular challenges that they have. There's a diversity in STEM symposium. There's a diversity in STEM dinner that you use. A lot of places are talking about summer bridge programs just to give people that kind of energy and confidence they need when they run up against the barrier. Talk a little bit about what's working.
Okay, so I've been here a long time. I've been at NC State a long time, since I was a student. And so I can tell you that a summer bridge program, NC State used to have a summer bridge program for students of color in particular. It was so successful that the university has a summer bridge program for all students now. So what you find, and this is for everybody listening, is what you find is a lot of programs that you develop for populations that are underrepresented in an area end up being very helpful for larger populations. And so that is such a program. And the College of Engineering still continues their bridge program for underrepresented students and women interested in engineering. But one of the models that I use in particular is called the Taylor Retention Model. And it looks at supporting underrepresented populations before they come to the university, all the way up through alumni. So it's a long view of their journey. And in particular, I use it towards STEM. So an example would be you don't recruit for STEM when they're juniors in high school. You begin to recruit for STEM when they're K-12. And so the College of Sciences has the Science House, which hosts many different K-12 programs. And in particular, two of them, they're open to everyone, but they're focused on underrepresented populations in STEM. And so these middle schoolers and elementary school students get they get to not only learn STEM, but they also have guest speakers come. They go to local RTP. It's a great place to be when you're looking at STEM. So they get to go to industry and see that real life connection. Because as Peter said and Thomas said, the real life connection is what a lot of students need to understand, why am I taking this calculus? And so in the College of Sciences, we have that. Now, once they're in high school and they might be interested, then one of the gatekeepers I saw to getting STEM students here is the SAT. I found that I had a lot of students of color interested in NC State and the sciences, but their scores weren't great in, say, the math portion of the SAT. And I do want to say that research does not show a correlation between your scores on the SAT and your success in college. But it is a gatekeeper. So, one of the things that came out of the pandemic is that not all schools are using those test scores, but traditionally universities have. So what we try to do in the College of Sciences is reach out to students who have met that threshold that should get them admittance into NC State, who said they were interested in STEM, and bring them to NC State for a weekend so that they can see campus, interact with alumni of color who've graduated in STEM, so that NC State can feel like, and that's what a bridge program would do as well. NC State feels like it's a part of home, that you are comfortable here. And so when school starts with everybody else, you already have a friend group, you already have people that you know who work for the university. And then the rest of the programs are really a continuation of that, getting connected, students connected with alumni, getting students connected with industry, getting students connected with great faculty and staff at the university. So when they graduate, it feels like home. And what I often find is those alumni reach back, not only financially creating scholarships for new students, but they also come and speak. They give insight to the college. So it's a long journey, but it's worth it, and for the success of students.
So some of those students are graduating, and for them, the bachelor's is the end of the line. Peter, you're trying to make the case that for a lot of them, the next step should be graduate school. What are you doing to make that transition easier? So for people who are obviously choosing to go to graduate school, but maybe nervous about coming in, or maybe have a really tough first semester.
Yeah, and I think I hear, Leslie, going to focus mainly at the PhD level. I mean, not to say that there aren't issues at the master's level as well, but I think, I think some of it certainly goes back to what Jamila was talking about. Can they picture themselves in that doctoral role? And, how strong is the imposter syndrome, and how do you deal with that? And although we haven't launched it yet, we are planning a bridge program for incoming PhD students because, the numbers continue to get smaller. I mean, even at the undergraduate level, at NC State, you may not have many people of color even within your major. When you get to the PhD level, that number gets even less. So how do you build a sense of community among those people? And before I came to NC State, I worked at USF in Tampa, and we had a close relationship with what's known as the Florida Education Fund. And they supply McKnight fellowships to students of color throughout the Florida university system. And they have just done a tremendous job. I mean, nationally, the completion rate of PhD students, for a lot of reasons, tends to hover around 55%. Their completion rate is 90%. So they're clearly doing something right. And I think that rightness involves a range of different things, but a big thing is building a sense of community, having this peer mentoring model that shows that, yeah, it's possible. You know, they bring back alums in the same way that Jamila was talking about, but they also really celebrate success. And, you know, that's such a critical thing, knowing that when you pass these milestones that, you know, yeah, it was hard for everybody, but they're also incredibly tremendous indications of accomplishment at a very high level. So how do you celebrate that? And, you know, it's kind of a trivial thing, but when the students graduate, they get these green jackets, and all of them, you know, they talk about that so much as being, you know, something that's driving them. So our goal is to try to create that sense of community here, and peer mentoring, and also bringing in faculty of color, because they're pretty disparate too on this campus, and thinking about how do we create an ecosystem that provides a tremendous amount of support both within the discipline and outside of, and, you know, create this sense of belonging to try to get beyond, you know, some of these issues that, you know, and I think it would probably be valuable to everybody, as Jamila is talking about, but I think it's especially needed for those folks who, as I mentioned before, are first time in college, and, you know, what does grad school even mean? What are the expectations, and so on? So how do we demystify that and really create a path of success? Because that's what we want with all our students.
Just to jump in on that also, so sometimes it's helpful. So when I was going through my process, going through grad school, I ended up connected with the Compact for Faculty Diversity, which is a part of the SREB, Southern Regional Education Board. And sometimes one of the big things that helped me, and I think helped a lot of us, was this connection and this network that was formed that wasn't just on that campus. It brought students of color, minorities, so students of color and women together off campus to kind of talk about their experiences. And it was good. It was a double-edged sword, because it was good to talk about the experiences you were having on your campus with someone off the campus, but then at the same time you were realizing they were having the same experiences on their campus. So it helped to bring to light what some things that maybe needed to be changed, but on the other hand, it showed you, okay, things are pretty similar everywhere. We're just going to buckle down and we're going to work this out. We can do it. So being a part of some groups like that can be very, very helpful, I think, in helping students to navigate grad school and ultimately to finish and find a job.
Speaking of finding a job, let me turn back to you, Peter, and ask you about the Accelerating to Industry program, the A2I program. This is an idea that the graduate school at NC State has started that has since become kind of a national model that is trying to send a couple of different messages to people who are graduating with graduate degrees. Can you talk a little bit about what the intent of the program is and what you're hoping to have?
Sure. You know, I think when, you know, one of the sort of areas of national conversation is, on the one hand, that we're producing too many PhD students. But that's when you view it through the lens of academia, right? I mean, the number of academic jobs has certainly not kept up with the number of PhD graduates overall. So you know, from my perspective, it's almost a moral imperative if we're going to be preparing these doctoral students who aren't all going to be able to go on into industry, and certainly, you know, being a land grant institution like A&T, that isn't necessarily the intent of every grad student. But ultimately, A2I is the notion that we need to train these graduate students to think about the skills that they've gained. And they've gained a huge range of skills in terms of, you know, data collection, data management, even team management. How do they translate that myriad of skills that they've gained into a package that basically coordinates with industry? And, I can't do that myself. As I mentioned, I'm a paleontologist. I have had a very academic career. I've had students who've gone on to industry, but I don't feel like I necessarily have the skills to effectively guide them and mentoring through that process of transition. In sort of a simple way, it's almost taking what we call a curriculum vitae, CV. How do you make that a resume for business? I mean, that's sort of a metaphor for how do you repackage yourself, rethink about yourself in a way that resonates with business. So what the A2I program attempts to do is to basically partner with various industries, and use those folks, in addition to the training that our professional development team does, to enhance that transition and to have students interact with people from industry, and through that immersion really think about, how do I view myself and how do I need to present myself in a way that resonates with a different ecosystem. And I think, that is certainly easier at a land grant type institution where historically the academic sort of pull towards academia as a measurement of success isn't as strong. But, we did get an NSF grant to expand this to numerous campuses across the country. And ultimately our goal is to have 30 partners across the country that are also initiating this program, because I think everyone realizes how critical it is to have an understanding of that really enhances what then our graduates can move into, once they're done with their degrees.
Let me show a statistic that is focused on undergrads, but it really makes the point, Peter, that you were talking about, and a lot of the work that both Jamila and Thomas have been working on, which is the importance of finding ways to make that transition. And this is just looking at it's a American Community Survey from the U.S. Census that's looking at people who majored in particular disciplines and then went on to work in those disciplines. And I've broken it out male, female, but you can see that among computer science and engineering majors, half or more of them among men are going on to work in those fields. Those numbers go down for the physical sciences and biological sciences, and the numbers for women in general are lower. So this transition from what you studied in school to where you're going to work is a really important thing. And Jamila, I'm wondering what kind of messages you try to send to the STEM majors about making that connection, that final connection. You have the degree and now there's an opportunity to go to work in that field. What is the message that students need to hear, or how can you make that transition easier?
So one of the things that I would be remiss if I did not talk about is the Women in Science and Engineering program at NC State, other known as WISE. And almost all of those inclusive type of programs understand that one, we need to have a connection not only with students and how they perceive themselves, but also connecting them with industry. And so WISE connects with all types of industry at RTP. It's a living and learning community. So the students actually live together in a dorm. So your roommate is also in WISE and has another STEM discipline. There's tutoring in the basement of the dorm, and alumni come and speak about what they're doing with their degrees. So it's a whole living and learning community that the whole essence is that you are here, you deserve to be here, and whatever that dream is, we are going to help connect you in as many ways as possible. So you need to see someone else who has done it. I'll give an example. Christina Cook, who's an astronaut, she has come and talked to the Women of WISE. It is one of our strongest programs at NC State, and it's very collaborative in that not only female faculty, which are important, but all sorts of men and women are involved with the WISE program. And I also wanted to go back to what Peter was saying about industry. Industry understands just how important it is that all voices and perspectives are a part of STEM. I often get the question of why is diversity important in STEM? And my answer is diversity is the world. That is how the world naturally is. So when you begin to see patterns of or areas that aren't diverse, then some obstacles have been put in place. And I'm in meteorology, but I love the earth sciences. And if you look at a stream and it's not diverse, that stream's in trouble. And that's just like industry, and industry understands that. So they partner a lot with WISE, they partner a lot with a lot of the colleges. And Leslie, you mentioned the Diversity in STEM Symposium, and I would be remiss if I didn't share that our partner with that is not only my great colleagues at NC State, but also BASF. And they helped fund that program. And they said, if you could do a program, what would you do? And we were dreaming, and we would invite students, faculty, staff, and the community. And I had a colleague say, well, you can't address all those groups. And I said, oh, yes, we can, and we will. And so we have workshops on all sorts of things, which is how to teach a STEM course inclusively, to how to negotiate a salary for, and faculty, staff, and students can attend any of these workshops. If you want to know what it's like to live a particular perspective, or you want to improve yourself. And we've done this twice and had over 300 people attend both the symposium and the dinner, but we couldn't do it without our colleagues in industry who understand that inclusivity in STEM is extremely important to the future, of not just the state, but also just globally. It's really important.
To pick up on something you said earlier, talking about feeling like a bit of an anomaly when you graduated with your PhD in meteorology as an African-American woman. And you also mentioned Christina Cook, and I just wanted to give just a little bit of history on her. She, as many of you know, was an NC State undergrad in electrical engineering, also got a master's from NC State in electrical engineering, went on to be an astronaut, and earlier this year participated in the first all-female spacewalk that's ever happened. But even she talked about how tough it is to be a woman studying or working in STEM. And I wanted to just play an excerpt from an interview she did on the NASA program with a woman named Jennifer Hudgens called NASA STEM Stars.
I think throughout my STEM career, I have faced challenges, and some of those are just overcoming the sense of being the only woman in the room sometimes. There were plenty of times in meetings or teams where I might have been the only female there. And, sometimes that ends up, turns into just funny anecdotes that come out of that. And sometimes it can be hard. It could maybe feel lonely. I think that's changing right now. So I hope that people that choose those STEM careers now don't face necessarily what I did. But for me to overcome that, I would think about the women that came before me when they were literally maybe the first person in their entire university, and the attention, the extra scrutiny, then extra expectation to maybe represent your entire gender, those things that they face so much more of than even I did. And it reminded me to be strong and to continue to give my best every day, and to focus on being the best I could be and be excellent in my job, and not just being there and participating. And that really helped me focus on the mission more so than the additional challenges that were brought along because I'm a woman.
Jamila, what do you hear from the women that you talk to about the challenges they face, and how are they working around it?
Well, first, before my physics colleagues kill me, she also has a bachelor's degree in physics. And to clarify for me, I have a bachelor's in meteorology. So it would be very unique if I was the first Black woman to get a PhD in meteorology. It was in science education. But I was the first Black woman to get a bachelor's degree in meteorology, for clarification for anyone out there. But for I hate to say it, but we're still breaking a lot of the first blank. I graduated a woman who was the first Black woman to get a degree in marine science, a bachelor's degree in marine science from here. So there are a lot of disciplines where we still have the first blank, and where young women feel like when they are they're not being asked to join labs, or they're the only ones in their courses, or they're having an issue with the class. And then they begin to internalize it as it's an issue with the selves. I'm not made out to do STEM. I'm not supposed to do this. And so I have a sign in my office that says, this is the truth zone. And so students know when we talk, I'm going to tell them the truth. So I care about them tremendously. But so that means I'm not just going to be the cheerleader, I'm going to be absolutely honest. So if it's let's look at how you're spending your time or how you're studying or study groups, and I know that it's not easy to be the only one that looks like you in a class. See, that's the one thing they know they can get from me, because I was like them and I had to do it. So honestly, that's why we try to create these family atmospheres. That's why we have WISE. That's why we have, as Peter and Thomas were saying, Thomas had to go outside of his institution to talk to others like him. And so, I tell students, let me send you to conferences, or let's talk to your department about sending you to conferences, because sometimes you can feel lonely here, but you can make that national or regional connection and feel that cohort, that family of people who are going through things just like you. I'll give you an example. So as the only Black woman in my meteorology classes, but now there's a Facebook and Twitter group for Black meteorologists. I would have died to have that when I was going through school, and I'm so glad they have that now. But there are communities like that all over the place. And so I tell students, not only can we form communities here outside of our disciplines, but also there are national and regional communities that you can tap into. And, as Thomas said before, the only reason I want to lose them to a major is because they found their passion somewhere else, not because any of the courses were obstacles to them. So we can work on the self-esteem, we can work on those things as long as they're passionate about that subject.
We need all those people if we're going to be successful in meeting the needs. One of the projects that, Thomas, I know you worked on earlier this spring, or late spring, was taking a look at the growth in what's called by some people in North Carolina across the innovation corridor. And one of the stats you cited was that between 2008 and 2018, there was an increase of 132,000 jobs in ag tech, biotech, data science, optics, life sciences. We showed some of those jobs earlier, some of the most recent ones from life sciences. But there's just a huge growth. And if we don't find a way to get everyone who's interested in STEM doing those jobs, then it's not that the jobs are going to go away necessarily. They might not come, but for the most part, it just means people from other states are going to come and take the jobs. And so if we can do a better job of graduating people in North Carolina with those degrees, then chances are we're going to continue to be successful going forward. What did you learn by looking at all those numbers that stood out to you?
Lord, everything. So it was very eye-opening, because for the number of institutions of higher education that we have in the state, and they're all great schools, our ability, the transition from the universities to the workforce, we need to do a better job of just retaining our own in-house talent, and for the diversity that we have in the state, we needed to do a better job of making sure that state level diversity translates to workforce and diversity. So I think that was a big part of what we saw. One of the things that came out of it, you worked with me on preparing that proposal, and that we started in one place. We thought we were going to look at this one aspect of it, and we realized as we were going through that our institutions are preparing a large number of minorities and women for the workforce. But if you're saying, say, that that's not being reflected in the workforce numbers, in the representation for the companies, then what's happening? Where are these people going? Are they not staying in that industry, but staying in North Carolina? Or are they leaving North Carolina and going to a different state to improve their numbers, and to be great researchers or great employees there? And, I personally like to believe that they're great employees, so they're going somewhere else and being great. And we need to do a better job of retaining them in state, and retaining them in the industry for which that they're pursuing. So one of the questions that we wanted to look at, that grant, of course, wasn't funded, but or we weren't selected to move to the next level. But one of the things that we wanted to look at was what's happening in those first couple years when students go into industry. We have a lot of programs for the transition from high school to college, say, and we support students and we support representation and mentoring and helping them to understand how things are different. And these are things you're just going to have to adjust to, and these are things that you can expect to be different than they are. So you can ask for them to be better or be improved when you move from high school to college. But when you move from college to industry, granted, different situations. Industry often is private, but when you cross that, what are we doing to help support students, and students of color in particular, to stay in that industry? And that idea came from, I should mention, since we're having the Geoscience Love Fest here, I actually do have a background in exploration geophysics, so we all should talk later. But one of that came from, I was a part of a program that purported to increase the number of minorities working in geoscience. And it was largely successful in most measurable aspects, in that students were graduating with the geoscience degree. But if you look at it a little bit longer and look at how many of those students who graduated are still actively in industry after, say, 5 years, and this is not in the state of North Carolina, but if you look at how many are still in industry after, say, 5 years, that number starts to drop. So there becomes a question of, why is that happening? Where's the disconnect? Is it something that the colleges are not doing a great job of in terms of preparation for the students? Is it something that the companies are not doing a good job of in terms of retention for those new employees and company culture? And so that's a big question that I think needs to be answered, or at least should be researched by whichever companies want to be progressive and want to retain good quality employees.
Peter, can you talk about the appetite that you found from the companies that are joining in and being part of A2I? We know that as we come out of the pandemic, a lot of companies are saying, where are the workers? Where are these folks that we need? And just seems like since you launched A2I, there's been an exceptional amount of energy from the employment community saying, yes, we want to be here with you. We want to meet these students. We want to capture them. We want to hold on to them.
Yeah, and I think, typically what happens at a university is that they have some sort of job fair, right? And that's really dominated by undergraduates. I mean, the people who we're partnering with are really looking for those PhD students that have that very high level of academic achievement, but also, as I mentioned before, come with all those skills. So for them, in part, it's an effective way to recruit, right? They get to introduce their company to a group that's exactly what they're looking for. And so I think for them, it's a huge advantage to get to meet these students, to see what these students are about in a way that is much deeper than just a job fair, right? I mean, they're looking to hire people sort of, for lack of a better term, higher up the industry food chain than, someone who's coming in at the bottom level. And so, I think it's just a great opportunity for them to see the skills. And, just to Jamila's been really good at telling stories, and I'm going to tell a story now, is that, because we have students from all these different disciplines, companies often come in thinking, well, we want specific students, from chemical engineering. And all of a sudden they get in touch with all of these different students, and their perception of what they're looking for actually changes. They're like, wow, we didn't realize that there were these skills, even within a humanities degree. I mean, not to downplay humanities degree, but they were really looking for those STEM folks. And all of a sudden, their perceptions as employers and what they're hiring for changes too. So I think it's an incredible synergy just in terms of, changing people's perceptions, industry's perceptions of what they're looking for and what sort of skills are needed. So I think, it's just a great to me, it's very much a win-win situation. Students are hearing directly from these industry folks, and industry's also hearing and seeing how these students interact.
Getting some comments and questions. I'll just mention a few of them, and please lob yours in, either whether it's your experience as an undergraduate STEM major or a graduate student, or the reason you decided to leave, or what worked for you to keep you in. So please feel free to share those ideas. Just a couple of comments that have come in. Some recognition of subtitles, which we've added to this feed. That's an important part, we think, of being communicators. Also, a salute of Jamila's comment about the importance of a supportive community. And finally, a comment about the importance of trailblazing stories. A lot of decisions can be made from anecdote, not necessarily data, but just seeing somebody, hearing a story, of someone who maybe looked or sounded or was somehow similar to you, and going, I get that. Yeah, I understand that. And those of you who work with public policy in general know that there is a crazy percentage of legislation that's passed every year that is made based on anecdotes. So a salute of the stories and how important it is to tell stories as you're trying to inspire someone to stick with it. So thanks to all of you for your comments. Please keep them coming. Jamila, can you talk just a little bit more about that community, since it was mentioned in the comments? You mentioned the Facebook group of meteorologists, but I'm guessing technology has made all sorts of support groups like that possible that wouldn't have been there 10 or 15 years ago.
Yeah, it has, because it really can connect you to the world. And so for the meteorologist group, I mean, job opportunities are on there. How to navigate the workforce. We had a student who was having an issue with a colleague, and again, every place has a culture, every field has a culture, and so they wanted to know, how do I navigate this without sabotaging my career? And so we were able to talk about that. For some of us who've been in the workforce a little bit longer. And I can tell you, when I was in graduate school and I was doing my research, I felt really isolated, and that my research wasn't important because my peers didn't seem interested in my research. And then I went to a national conference where I met, you're reading journal articles with the faculty, and then you meet that faculty member and they tell you you're doing a good job. And, it just, graduate school is hard, but that tank was filled when I would go to these conferences, and it informs my work in that sometimes when students are feeling that isolation, not only do they have community here, whether it's my office, we have snacks, we have drinks, we have, they know it's an open door policy, but also there are lots of different groups like WISE, the Society for Multicultural Scientists, Novachet. So there's, communities like that. But also these virtual global communities in which they can get on TikTok or Facebook, or I know Facebook's probably not their thing anymore, but they can get on all these spaces and connect for scholarships, for fellowships, for all sorts of things. And so just knowing that not only do they have a community of folks who look like them, but I have colleagues that I know of across of the world that I can say, Peter's a really great guy. You should connect with Dr. Harries when you come to NC State, because that's also important, that they know that there's a network of people who are allies who can support them.
All right, Jamila, let me call it there. I got so wound up in this, I wasn't watching the time, and so we need to call it a day for this. Thanks to you all for being with us. I really appreciate your time. Thomas Redd, Associate Professor of Mathematics at North Carolina A&T State University. Jamila Simpson, the Assistant Dean in the College of Sciences, and Peter Harries, the Dean of the Graduate School at NC State. Thanks to you all for being with us. Really appreciate it. Our next program is Tuesday, August 3rd, and you're going to want to tune in. With the Olympics underway, we're calling it The Power of Sports. And we'll be looking at the economic impact of sports in North Carolina. Join us for a special interview with NC State alum and 100-meter hurdles Olympian Gabby Cunningham. We've taped an interview with her. She's on her way to Japan right now, and so we have taped an interview with her. You'll want to hear that. We'll also talk with Hill Caro, who's leading the U.S. effort to bring the World University Games to the Triangle in 2027. It could be the most exciting big sports event that our state has had in some time. And David Joyner, the head of the Rocky Mount Events Center, who can talk about the economic impact of amateur sports in his city. First and Future is produced by James Herrick. Kirsten Chang does our social media outreach. Simone Coleman helps with research. Renee Potts does our slides. I'm Leslie Boney. For all of us at the Institute for Emerging Issues at NC State, thanks for joining. We'll see you in the future.